So scatter plots is the fourth section of chapter 4. And what a scatter plot is, it's just a kind of a specific type of graph that shows the relationship between two different data sets. And it can be a lot of things. It could be somebody's height based on their age. It could be somebody's like how much they can lift based on how much they work out. Things like that. You can think of a lot of scenarios that would work. And instead of like most of the time when we see graphs, or we've seen them so far, they've been connected. Now there's just going to be kind of a bunch of points spread around our graph, and we're going to make kind of conclusions about what the data is telling us based on, how the points are made. So that's basically summarizing what it says in this box here. A scatter plot is a graph that shows the relationship between two data sets. The two data sets can be regraphed as ordered pairs. So an ordered pair is just another word for a point in a coordinate plane, and a coordinate plane is just our fancy math word for a graph. So we're going to do this first example. So the scatter plot shows the amount x. So that's what's going to be on our x-axis, and the unit is grams. It's the amount of grams of sugar and the number of calories, so that's going to be on our y-axis, so the one that goes vertically, in 10 different smoothies. So let's look at the graph here first. So you can see how we were talking about on our x-axis, so the one that goes horizontally. We have sugar and grams, and that's our x value. And then our y-axis is calories. And we know we're talking about 10 smoothies, it says, because there's 10 individual dots. If you were to go through and count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And notice each just looks like a point. All right. So that's an example of what a scatter plot could look like. We're going to answer a few questions now about the scatter plot just by using what's given to us. So the first question is, how many calories are in a smoothie that contains 56 grams of sugar? Well, we already established where we can look to find out sugar in the smoothie is going to be 56. So if you notice, if you see your graph, it kind of has this little crinkle in it from 0 to 46. That just means there's no data to put there, so we kind of just shorten our graph. And our boxes are going up by 4 each time. So looking for 56, that's going to be directly in between 54 and 58. So each box is going up by 4. Half a box would go up by 2. We find 56. So if you just look straight up from 56, and if you even want to put it on there, you can say, well, 56 is right here. We go straight up vertically, you can see we hit a point. That smoothie, that dot, has 56 grams of sugar. And then if we look to the left, we can see how many calories it has. So we do the same thing. We look to the left. Say, okay, well, what that one point is telling us is that specific smoothie that has 56 grams of sugar has 270 calories. So that's what we're going to put for answer 1. We're going to say 270 calories because we want to use units since it's given to us. All right. Easy enough. Second one is, how many grams of sugar in the smoothie that contains 320 calories? So now we're looking at calories to start and not sugar. So we're looking at our y-axis. We look, okay, well, 320 is at the very top. Instead of going up to start, we're going to go to the right to start until we find a point. We have that smoothie there. Then we look down. We end up at 70. So 70 grams of sugar, 320 calories, or vice versa. You may even see this sometimes written as a point, like 70, 320. Since you know your units, you know what both of those numbers mean in context. So for problem 2, we would write 70 grams of sugar. Or we could just say 70 grams, since we already know we're talking about sugar. Which is a lot of sugar, especially for a smoothie. And this is where with scatter plots, the easiest thing that they let us do is make predictions about data without actually having any. Right? So the question is, what tends to happen to the number of calories as the grams of sugar increase? So can anybody make a prediction? As we have more sugar in the smoothie, what's happening to the number of calories? Going up. But you just, if you have basic knowledge of health and food, you could figure that out too. We have, when we're talking about graphs, we have something called correlation. We call this positive correlation. If you take those two kind of positive correlation, those are two big math words. If you put that into plain English, as one goes up, so does the other. So like the example I mentioned at the start of class, if you work out more, you're going to be able to lift more weights. That's positive correlation. As you get older, your height increases. That's positive correlation. But then it comes a point where you start getting old. Now you have what we call negative correlation. Whereas one unit goes down, the other unit goes down as well. And there's something called no correlation, where you can't really see two things that are not related. So like the amount of food you eat and I don't know, when your birthday is. Those two things, not correlated. So now we're going to do some of the scatter plotting on our own. It says the table shows the weekly sales of DVDs. I know you guys probably are way past. DVDs were cool when I was young. DVDs, you guys are in the age of streaming. Shows the weekly sale of DVDs and the number of weeks since its release. So on week 1, sales were $19. Week 2, sales were $15, so on and so forth. First thing we're going to do is make a scatter plot of the data. And we have a totally blank graph. So first thing we have to do is add our units to our axes. So if it's an X, like it's already set up here, the week is the X value. That means it's going to go on our horizontal axis. So we would put week. Oops, I don't want to write in my highlighter. We would put week. And this is our X. Our Y-axis is going to be money. Or so, because since we're talking about sales. So we can just put a little number, a little money symbol. And boom. Also, we need to add our own scales to this graph. All right. We see that our X values go through 1 through 8. We're going through 8 weeks. So we have enough where we can just have each box be 1 week. So that's 1, 2, 3, 4, 5, 6, 7, 8. You don't have to write out every one. Sometimes I just write like the 1, the 5, and the last one, 8. We can't do the same thing for our y-axis because our highest number is 19 and our lowest number is 5. So if we were just to go up by 1 each time, we'd only get up to, would that be 10? If we go up by 2s, we would get up to 20. So we're going to use that. We're going to go up by 2s here. We're going to say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So now we just have to plot all these. I'll plot them in red. So on week 1, the sales are $19. So that's going to be halfway in between 18 and 20. That's 19. On week 2, it's $15. So that's going to be in between 16 and 14. Week 3 is $13. Week 4 is $11. Week 5 is $10. Week 6 is $8. Week 7, $7. Week 8 is $5. All right, so it kind of makes a perfectly straight line. All right, they're not exactly in line, especially that very top one. It's out of the pattern. But you can definitely see there's a correlation. As weeks are passing by, the sales are going down. So we call that negative correlation. What we're going to do is write an equation, what's called the line of best fit. So we're basically going to try to draw a line that goes through all of them as best we can. So this is where you're going to estimate. You're going to see, okay, how can I draw a line that goes through as many points as possible? Well, it's not going to be perfect. You're not going to be able to get through them all without making, like a little curve. So you're going to try to say, okay, well, I somehow split the difference between up here and all my other dots. So your line of best fit, everyone's may look a little different. So that's what we could call a line of best fit. It doesn't go through exactly every point like we would when we'd be like graphing slope or something, but it's pretty darn close, and it gives a good representation of how sales look as time goes on. And what we can do with this is write an equation in slope-intercept form. So y equals mx plus b. We know we have a starting point. We start up here at 19, so that'll be our b value. If you count box to box, it looks like we're going down 2 over 1 each time. Down 2 over 1, down 2 over 1. Again, I'm not following the dots. I'm following my line of best fit. Down 2 over 1, down 2 over 1. So we have a slope of -2. So an equation for this line could be y is equal to negative 2x plus 19. Again, y equals mx plus b. Our slope, -2. Like on average, sales are going down by 2 each week. And we're starting, 19 was our starting sales amount. And that's what it means by interpreting what your slope and your y-intercept of the line of best fit is. So we could say -2 means sales are, you could say, decreasing or going down $2 every week, or $2 per week. And your 19, or your B value, is that the sales start at $19 per week. So I'm sure if you took in real life, like the sales of DVDs, I would bet money that like 5% of you have ever actually went out and bought a DVD. Has anybody ever actually gone out and bought a DVD? Okay, that's about 5% of there's 1, 2, 3, 4, 5, 6 of you. 7. That is about 5%. There's, but I bet if you would take like the trend of just everything in total, I bet it's probably there's more money in DVD sales than just this, but it's definitely going down, right? So I could even predict using this. I could say, okay, what's going to happen after, I don't know, 15 weeks? Since I have a line of best fit, if I was to extend my graph out, it would probably be like, oh, well, I'm not selling any more DVDs after 15 weeks. It looks like our DVD sales are going to stop. We go, that would be 9, 10, 11, like after 11 weeks of this. We're talking about like a particular store. You can make predictions based on that line of best fit.